Hello, hey y'all. In this lesson, we are looking at adding and subtracting numbers in scientific notation. So we want to be able to perform these operations with numbers in scientific notation. So our big things here is to add or subtract, numbers have to have the same power. We will often need to rewrite our answer so it is in proper scientific notation. Our essential question: how does using scientific notation help when computing with very large or very small numbers? In our first example, we'll look at adding numbers in scientific notation. So we are going to add 8.8 times 10 to the 7th plus 3.1 times 10 to the 8th. Now we could write these numbers out and do our addition, or we could keep them for the most part in scientific notation. Now, what we're going to do is first use a property of exponents to rewrite 10 to the 8th as 10 to the 7th times 1. So we want to have the same power of 10. So we rewrite this, 8.8 times 10 to the power of 7 stays the same. And then 3.1, we'll do this as times 10 times 10 to the 7th. So now they both end in 10 to the 7th. And we will simplify, okay? And so I kind of did that in these two steps, did it in one, put my times 10 at the beginning. And now we'll factor out, because they both have 10 to the 7, we'll factor that out to the end, and when we factor that out, we have 8.8 plus 3.1 times 10, and it's all of that times 10 to the 7th. So we're using the opposite of the distributive property to take that power of 10 out. Inside the parentheses, we'll multiply 3.1 times 10. We now have 8.8 plus 31. And then we simply add those together. 39.8 times 10 to the 7th. We now need to rewrite this in proper scientific notation, which means we need to move the decimal over 1. And because we move it over 1 to the left, we'll add 1 to our exponent to get 3.98 times 10 to the 8th. And this is our answer properly written in scientific notation. Do future you a favor and make sure to rewrite why we did each of the steps that we did. In example 2, we're going to look at subtracting numbers in scientific notation. The mass of the Earth and the mass of the Moon are shown. How much greater is the mass of the Earth than that of the Moon? Because we want to know how much greater it is, we are looking for the difference. That's why we're subtracting. So we will want to subtract the two values, but we can't just subtract the first part of the number. We can't just take 7.35 and subtract 5.97. So one way is to rewrite these in standard form and then subtract them. So 5.97 times 10 to the 24th, the mass of Earth, would be 5,970. And then we've got 3, 6, 9, 12, 15, 18, 21 zeros. That's a lot. Rewriting the mass of the Moon in standard form, we have 73, 500, and then 3, 6, 9, 12, 15, 18 zeros. Now we subtract. Minus. My two numbers lined up really nicely, so we have all of these zeros, so we have zeros all the way here. And 0, 0, we have to borrow. Remember my borrowing rules. There we go. I got the same answer as is on the screen. 5,896, 500, and then a bunch of zeros. And we can rewrite that in scientific notation. We got 18 zeros, 19, 20, 21, 22, 23, 24 spots. So 5.8965 times 10 to the 24th. Okay, the difference is about 5.8965 times 10 to the 24th, kilograms. So we wrote out a ton of zeros that really aren't necessary. So let's look at using the same way we added to subtract, because this is problematic because it takes extra time. You need to make sure everything is lined up correctly. If you make one small mistake, you can end up with a completely inaccurate number. So let's look at using the same power of 10 and then subtracting. So just like before, we want to take our larger power of 10, 5.97 times 10 to the 24th, and we want to rewrite it so that we get times 10 to the 22nd, which is what the power of 10 on the smaller number is. So we rewrite this as 5.97 times 10 squared. Because we have 24, we want to go down to 22, so we need to take two 10s and then times 10 to the 22nd. Now I rewrite that 5.97 times 10 squared is 597 times 10 to the 22nd. Now I can subtract my mass of the moon minus 7.35 times 10 to the 22nd. When I subtract them, right, I'm just subtracting the first numbers now because this is going to be times 10 to the 22nd. So I'm just subtracting these numbers. I'm not actually subtracting this. This gets factored down into my answer. And when I subtract, I give it 0.00 to help with my place values of subtracting. And I get 56.985, just like they do, times 10 to the 22nd. And then again, I'm going to move my decimal over 2 spots to the left. So I'll increase my number by 2. So I end up with 5.8965 times 10 to the 24th. And notice that these are the same answer. Okay? So with my subtracting, I made them have the same exponent or the same power, subtracted the larger from the smaller number, and kept the power of 10. Then I just rewrote my answer in proper scientific notation. When you move that decimal to the left, your power is going to go up. On the back side is a problem for you to try. The planet Venus is on average 2.5 times 10 to the 7th kilometers from Earth. The planet Mars is on average 2.25 times 10 to the 8th kilometers from Earth. When Venus and Earth and Mars are aligned, what is the average distance from Venus to Mars? So Earth is here. This is Earth. Venus is on one side and Mars is on the other. Okay, so when they line up, we're going to add those two distances from Earth to figure out what is the total distance here. So fill in the blocks and then resume the video to see if you got it right. Don't forget to take a final look at your summary. Operations with very large or very small numbers can be carried out more efficiently using scientific notation. The properties of exponents apply when carrying out operations. So you can move things around and factor things out by using those properties of powers or exponents that we learned about before. So you can see one final example of adding. So when we go from one step to the next, we want to factor out a power of 10 so that they both have the same power in one location. We can apply that power of 10 to the original amount to simplify that. Add our two beginning numbers, keeping the power of 10. We get that. And then put it into proper scientific notation. Usually you'll end up with the same larger exponent. Your next steps are to submit your 9.5A notes, complete your build 9.5A, and then take your 9.5A mastery check. Good luck.